Welcome back to the continuation of lists, stacks, and queues. We're going to just continue on algorithms and data structures. In our previous session, we were talking about linked lists and basically just the fundamental idea behind it. And again, I realized that there's a lot of concepts that you need to understand, but I hope that video gave you a basic understanding of linked lists as a concept in itself. I'm going to try my best to actually give you working material so that you have a fundamental feel of everything. But for now, just please try best to understand the video. And again, you can text in the WhatsApp group, or you can just leave a message within the comment section, and I'll get to you as quickly as possible. Okay, without further ado, let's begin. So, what is a stack? Well, a stack is a linear data structure that follows the last in, first out principle, right? Where the last element is added and the first one is removed. So, essentially, we have this type of situation whereby you have a stack there, right? So you put in information there, it comes in, you've got this guy, you've got that guy there, you've got that guy, you've got that guy, and so on and so forth, right? Until the stack is full, right? So the last one in, if I put a last value in here, right, that's going to be the first one to come out. So that's what the last in, first out principle states. So the last element that is added is the first one to be removed. So operations that take place in a stack are push operations, where you add an element to the top of the stack. So meaning if you have this guy here, if the stack is empty, a push operation is basically just adding something there. A pop operation removes the top element from the stack. So let's just say you've got all this information here, and then you've been putting. A pop is just basically going to remove this guy out of the stack, and then a pick, basically top, returns the top element without removing it. So if you want to see what the top element of your stack is, you can use a pick operation. And then if empty, basically checks if the stack is empty. Okay, so a visual representation of this is an empty stack looks like this, whereas a push operation is basically you're pushing in an element within your stack. You can push another element in the stack there, you can push another element in the stack until it's full. Then a pop basically just says remove the top element. So you can have another pop which removes the top element, and then up until the stack is empty. Okay, that's just a brief understanding of that. Okay, cool. So implementation in pseudocode, just put this guy here. So implementation in pseudocode, basically here we have a function create stack, and you've got a stack which is an empty list. So if you're in Java, you might get maybe like an array, right? An empty array, then return the stack. A push operation basically gets the stack itself and then the value of what you're trying to add. So you add the value to the end of the stack, then you end the function. There's a pop operation, you get a function where you pop, you get the stack as a parameter, right? So for example, let's just say you've created an array, right? So a function pop here will get the array as the stack, and then if the stack is empty, then print stack underflow, then return now, and if then return remove the last element from the stack. So the operation that is going to be there is you get that guy and then you just remove it. For stacks and queues, the pseudocode isn't really that mandatory, right? Writing code, unless maybe your curriculum has changed. But for stacks and queues, or in my intake last year, we didn't have to let's just say write pseudocode for those. So we just had to understand the operations and everything. So a pick operation basically looks at the top element, then there is empty, as I explained earlier on. So here, don't focus much on the pseudocode because I doubt it's going to ask you that question. But if it does, then you just have to understand that this is essentially how you do that there. Okay, so yeah, I know stacks was really, really short, but then yeah, queues. So a queue is a linear data structure that follows the first in, first out principle. And we know what the queue is, right? So the first person in the queue to the ID room is the first person out, right? So yeah, you have that operation there. So a queue has operations which is enqueue, which is add an element at the end of the queue, right? So we have this type of arrangement here where if nobody is there, right, you enqueue, so meaning you add someone at the end of the element, which is at the first there. The queue removes the front element from the queue, so meaning if we have more than, you know, 3 people, 4 and 5 and whatnot and everything there, let's just put this. So if these are people, if you have to dequeue, then this guy goes out, right? Then you remain with this guy here. Let me just put this as a pipeline. So if you're on your way to Nadia's, right, and then you want to buy a shawarma, right? So what happens is that you're gonna find a queue. So the first person, if there is no line, then you're queuing yourself in the line, right? So you put a queue there. When the cashier gives you a shawarma or gives you your pie, or gives you your fruticana or whatnot, that cashier has dequeued you from the queue. It's pretty self-explanatory, right? So it moves you from the queue against the next person, then dequeues, and so on and so forth. A person who wants to buy new food or whatnot, they queues themselves. Okay. Then front peak returns the front element without removing it. So let's just say you're at Nadia's, right? And then the shawarma man is trying to find out who's getting the shawarma first. So there, the shawarma person is peaking on the queue, right? And then it's empty, checks if the queue is empty. So, you know, if it's a slow business day, then yeah, there's nobody there on the list. Okay. So this is basically what the data structure looks like. Last in, last out, first in, first out data structure, pretty self-explanatory, right? And then here we've got queue implementation, where you know you've got creating the queue. It's the same as the previous one. And like I said, the only concept that you need to familiarize yourself a lot is linked lists, because linked lists are the ones that are the most important. I mean, yeah, you can understand queues and stacks and everything, but then linked list is where the actual operations are happening, right? These ones are easy to understand. You can easily implement it in Java, Python, whatever language that you feel like. So yeah, we've got creating the queue, we've got enqueue, with the queue, we've got the front operation, and then there is empty operation. And like I said in the previous one, in the previous session, I'm gonna try to provide Java code for you guys so that you'll be able to implement it and then you actually run with it. So you have that to practice and see that information firsthand. Okay. So now the thing is, we have to understand the differences between stacks and queues, right? So here we've got our feature, we've got our access order, insert an operation, remove operation, and the use case that we use for that. So for our stack, right, the access order is a last in, first out. So the last guy in is the first one out, whereas the queue, we follow first in, first out, right? So the insert operation is called a push in a stack, and then in the queue, it's called a enqueue. Removing of an operation is a pop, whereas in a queue, it's dequeue. And then the use case is to undo a mechanism or expression evaluation, basically for a stack, whereas a queue is used for scheduling, right, or print queue. So things to do with schedules or whatnot, but yeah, those things that have a queue, right, where you follow the order of operation, where somebody comes in first, is the first one to be served, right? First come, first serve is the same thing as first in, first out. So that's the queue operation. Then the stack basically just follows the, let's just say, you want to fill in a bucket, right? With water, you have to drain the water out as well. I mean, there are options whereby you can have a bucket uh, where you put in your water, right? And then you can just start draining the water out. But for it to drain water, you have to put in water within the bucket there. But then there's some buckets that have got like a tap somewhere at the bottom there. So some buckets also follow the cube, right? So the first in, first out. But then, yeah, you get a general idea between the two. Okay. So now, this session is going to be relatively short because there's nothing much to talk about with stacks and queues. So we use stacks for backtracking problems, right? So browser history, recursion calls, etc., etc. You use queues for task scheduling, right? So job scheduling, breadth first search, and graphs. Two stacks can be used to implement a queue, right? And two queues can be used to implement a stack. So there is that. But then beware of stack overflow, meaning that we exceed memory, and queue underflow, where we're trying to remove from an empty queue. So this can be taken as a tutorial session where you're just understanding the concept behind queues and stacks. Because he might ask you, or Dr. Nyirenda might ask you to say that, what exactly is the use case for a stack and the queue, or what are they used for, or where are the use cases for? So you at least have an understanding or an idea when it comes to concepts, because you can't tell Dr. Nyirenda say that a queue is where you go to Nadia's and then you go and eat and then do the things that you want to do, etc., etc. No, you have to use actual programming or computing problems that implement stacks and queues. So at least this should give you an idea of what exactly is implemented within those guys and whatnot. It's a very short tutorial video. I think it's not less than 5 minutes. I'll be shocked. But yeah, so this is basically everything that you need to know about stacks and queues. The only thing that is more demanded is linked lists. Okay, of which again I said that I'm going to post some content for you, so don't worry about that. But for now, we just have these guys here. Okay, so I hope this was very informative. Again, as usual, if you have any questions, please leave a message down below, or you can just text in the WhatsApp group, and then I'll get to you as soon as possible. For now, thank you so much. Take care and be blessed.